Good morning to everyone. We are making a video on nature of roots of a quadratic equation. Now, when we talk of the nature of roots of a quadratic equation, what is it? Now, you realize that when you have a quadratic equation, for example, if I give you a quadratic equation like s squared plus x minus 6 equal to 0. Now, this is a quadratic equation. I can give you another quadratic equation like s squared minus 8x plus 16 equal to 0. I can give you another one like 2s squared plus 4x plus 5 equal to 0. Now, I can ask you to solve this quadratic equation or find the roots of the quadratic equations. They are the same. Now, try and solve these three equations on your own. You can either use the formula. The formula is x is equal to negative b plus or minus the root of b squared minus 4ac all divided by 2a. Try and use this formula to solve. Now, after solving these three quadratic equations, you will realize that the answer to this is 2 and negative 3. You will realize that the answer to this one is 4 and 4. And the 4 and 4. Then the answer to the last one will be negative 1 plus or minus the square root of 6 all over 2i. Now you can see that they are all having different roots. All these values are real numbers. 2 and 3 are real numbers. So this root is called real root. Real, but you can see that 2 and negative 3 are different. So we call it real but distinct roots. Now, this 4 and 4, this 4 and 4 is called, they are all real numbers. 4 is a real number, but we are getting equal real numbers. So we call it real but equal, real but equal roots. Then when you come to this very number, this number here, or this very value, the value here is not a real number. So we call it not real root. Now, if it is not real, then it is what? This number is a complex number. So we call it a complex root. Whenever you see a number with this I symbol, the I is an imaginary number. It's an imaginary number, so it makes the whole number a complex number. So you can see that the nature of root of a quadratic equation, the root can be all real. That is, this and these are all real numbers. But the difference is that this one is real but distinct, because you can see that the roots are different, 2 and negative 3 different. Here we also have real, but you can see that 4 and 4 are the same. So real but equal roots. This one is a complex root. Let's take note of that. Now, having known this, now let's consider the quadratic equation ax squared plus bx plus c. That's the general quadratic equation where a is not equal to 0. The roots of the equation are given by, so anytime you are solving a quadratic equation, we use this formula to solve. That's the quadratic formula. In the quadratic formula, you can see b squared minus 4ac inside this very function. B squared minus 4ac. This b squared minus 4ac is called the discriminant. It's called the discriminant. Now, this discriminant helps us to determine the nature of roots of a quadratic equation even without solving. You realize that here we solved to determine whether they are real, whether they are complex. But with the discriminant, we can just determine the nature of roots without solving. Anytime you calculate the discriminant and you realize that the discriminant is greater than 0, if the discriminant is greater than 0, then we are saying that the quadratic equation will have 2 distinct real roots. Let's take note of that. Now, when the discriminant is equal to 0, then the quadratic equation will have 2 equal roots. The root will still be real roots, so equal real roots. But if the discriminant is less than 0, then it means that it has no real roots, or the root here is a complex root. So here you can see complex root. Let's take note of that. If a quadratic function has a complex root, it means that that function does not intersect with the x-axis. So you realize that this curve is above the x-axis. This same curve can be also drawn like this. It can also be below the x-axis. It shouldn't cut the x-axis. When it is equal to, then it means it intersects the x-axis at only one point, and that point is the equal root. But when this one just touches it, this one it touches, but here it intersects. Here it touches the x-axis. Here it intersects. Here it does not intersect. It will be either above the x-axis or below the x-axis. Let's take note of that. So this is a summary of the formulas. B squared minus 4ac is always called the discriminant, and the discriminant, when greater than or equal to 0, then the equation will have 2 real roots. So let's take note of that. You realize that here, when it is only greater than, it has a real distance. When it is equal to, it has 2 equal real roots. This one is still real. Let's take note of that. It's equal real roots. So this is real. This is also real. that is greater than and equal to. They are both real. So when you put greater than and equal to, when you put them together and make it greater than, b squared minus 4ac is greater than or equal to 0, and it means we are just talking about real roots. But in between the real roots, we can have a distinct real root and we can have equal real root. So I can put it this way, a big set. Now, this is real root. Now, in the real root, you have b squared minus 4ac is greater than or equal to 0. Then, I can have two different sets here, 1 and 2. Inside the real root, I can have equal. Then I can have distinct. For the equal, b squared minus 4ac should only be equal to 0. Then with the distinct, we have b squared minus 4ac should be only greater than 0. But when you put the equal to and the greater than, then you make it greater than or equal to, then it means that it is real. Is that right? So this one is equal real. This one is distinct real. Normally the equal real, normally they don't bring the real, they just make it equal root. But you have to know that it is real root. Alright. So that is it. So if the b squared minus 4ac is greater than or equal to, then the equation will have two real roots. When it is only greater than, then it has real and different or distinct real roots. When the b squared is also equal to 0, it has real and equal roots. When it is less than 0, it has a complex root. It has a complex root. When b squared minus 4ac, so that one stands alone on its own. Complex root. That is when b squared minus 4ac is less than 0. Let's take note of this and let's move on to another thing. I want to explain the graph of quadratic function. Graph of quadratic function. Now let's say you have a quadratic function of the form as squared plus bs plus c. If you have as squared plus bx plus c equal to 0, if you want to, the equal to 0 doesn't begin okay? If you have as squared plus bx plus c, let's say greater than 0. If I want to sketch this curve, it's going to be this curve because a is greater than 0. If a is greater than 0, if a is greater than 0, then it means that a is positive. Well, let me write it. If a is positive, if a is positive, we are going to get that it means that we have a minimum curve. So we are going to get the curve like this. This will be the curve. That is if a is positive. We have a minimum point. Now with this minimum point, let's say here is a. Let me name it as P and Q. Now from here, because it is greater than, we are interested in the region which is above. We are interested in the region which is above. Because of the greater than sign, we shade above. Whenever you are shading above, we shade this region. So this is the region to shade. This is the region to shade. This is the graph of this function. And with this graph, the solution is going to be x. This part is called x is less than or equal to p. And here is x is greater than or equal to p. Okay, let me correct it. Because the symbol is just less without a equal to, the greater than without equal to p, x is less than p and x is greater than p. That is the solution. So the solution is going to be x is less than p or x is greater than p. Let's take note of that. Now the next thing is, let's go to 2. If you have a quadratic function, the same function, which is ax squared plus bx plus c, this time it is less than 0, but a is still positive. If a is positive, if a is positive and you have ax squared plus bx plus c less than 0, then the graph is going to be at a still minimum. It will still be minimum because a is positive. You have a minimum function. So you still get the same thing with your p here and your q here. But this time, because the function is less than, because of the less than symbol, we shade below the x-axis. In shading below the x-axis, we shade here. This is where we shade. Now, when we shade this portion, it means that the solution to this inequality is from P to Q. It's from P to Q, which is P is less than or equal to. Now, because it is just less than, let's use P is less than X less than Q. That is the solution set. So the solution set to this one is going to be P. X is such that P is less than X less than Q. That is going to be the solution to this. Let's take the third one. Now with the third one, if I have ax squared plus bx plus c, this time I still have greater than 0. But here the assumption is that if a is less than 0, now if a is negative, if a is negative, then what happens? It means that we will have a maximum function. So we are going to get the curve as maximum function. In this case, P is here and Q is here. This is our x-axis. Because the inequality sign is greater than, we have to shade above the x-axis. So we shade here. Shading above the x-axis, we shade inside here. Anytime you shade inside, the solution becomes P is less than or equal to S less than or equal to Q. That is from P to Q. So we see that S is such that P is less than or equal to S less than or equal to Q. That becomes the solution set to this quadratic inequality. Then lastly, if you have AS squared plus BS plus C, when this time it is less than 0, and if A is negative, if A is negative, because A is negative, you will still have a positive function. That is, the curve will be having a maximum curve. So we will have a maximum curve like this. But in this case, this is your x-axis. Remember, it is less than, because it is less than, the inequality sign is less than. So you shade below the curve. You shade below the x-axis. In shading below the x-axis, you shade this region. You shade this region and this region. Now, if you shade, remember that this is your P and this is your Q. So in shading this region, it means that here X is less than P. Then here X is greater than P. So the solution set is going to be S is such that X is less than P or X is greater than P. That becomes the solution set to these inequalities. You will be applying this. Anytime you have a quadratic inequality and you want to solve, you can also stick to this. Instead of using the number line, you can apply this concept. Now let's take our first example. Describe the nature of the roots of the following equations. So I will just solve 1 and 2 for you, and you try the remaining ones. Solution. We have the first one, I, to be 2s squared minus x minus 1 equal to 0. So from here, we know that our A is equal to 2. Our B will be negative 1. And our C is also negative 1. So what we need to do is to find our discriminant. We know that our discriminant is B squared minus 4AC. So it is this function that we use to determine the nature of the root. Let's substitute our values into it. We know that A is 2, B is negative 1. So start with negative 1, which is B, all squared, minus 4, A is 2, then C is negative 1. We know that negative 1 squared is positive 1. Then negative will also be positive. 4 times 2 is 8. So the final answer is 9. Now the question you ask yourself, this value we have gotten is the discriminant, B squared minus 4AC. Is 9 less than 0 or 9 is greater than 0? Now you realize that 9 is greater than 0. If it is greater than 0, then we are saying that B squared minus 4AC is greater than 0. And if b squared minus 4ac is greater than 0, what does it mean? Then it means that the root of this equation will have a real but distinct root. Therefore, the root will be real but or real and different root. Real and distinct root. So because b squared minus 4ac is giving us a value which is greater than 0, we conclude that this quadratic equation has real and distinct roots. Let's take another example, which is I. We go up I. So we are taking the next one, which is s squared plus 5s minus 1 equal to 0. Here too, we know that a is 1. We know that b will be 5 and c is negative 1. Let's put our discriminant is b squared minus 4ac, which is equal to, now let's calculate that. Let's substitute the values into it. Our b is 5, so 5 squared minus 4, a is 1, and c is negative 1. So we have 5 squared, which is 25, minus negative is positive 4. So finally, we are getting 9. Now you realize that 25 plus 8 will give us 29, sorry. Now you realize that b squared minus 4ac is 29, which is greater than 0. Therefore, we conclude that this equation, the equation has real and distinct root. That is it. Let's try the third one. Then we'll end. We'll do the rest. Okay, so let me do the third one here. We have 3s squared minus 2s plus 4 equal to 0. In this case, a is equal to 3, b is equal to negative 2, c is equal to 4. Let's use our discriminant, b squared minus 4ac. b squared minus 4ac. Let's substitute the values into it. We have negative 2, all squared minus 4. A is 3 and c is 4. So negative 2 squared is 4. Then here becomes minus 4 times 3 times 2. What is it? 4 times 3 times 4. 4 times 3 times 4 is giving us 48. And when you subtract, you get negative 44. Now, we know that negative 44 is less than 0. So because b squared minus 4ac is giving us a value less than 0, the conclusion is that therefore the equation has no real root. It has no real root. If it has no real root, what it means is that it has a complex root. That's the meaning. We are solving. Let me see what I can solve one more. Let's see. the last one. Um, let's take Ivan. Ivan is 2x squared minus x plus 3 equals 0. Our A is 2. Our B is negative 1. And our C is 3. So just go ahead. Your determinant is b squared minus 4ac. Put b inside. We have negative 1 squared. Then minus 4. Your A is 2. And your C is 3. So here too you have 1 minus 4 times 2 is 8. 8 3 is 24. So we are going to get minus 24. And 1 minus 24 is negative 23. So because b squared minus 4ac, negative 23 is less than 0. Consider it will have a complex root. It has no real root, or it has a complex root. Let's take note of that. So these are the basic solutions. These are the basic solutions. So you can try them later. Now, before we try them, you can try these ones. The answers are there. I want us to solve the game. Then you see how the game is. Or even the first one. Let's solve the first one. The first one here is going to be x squared minus 6x plus 9 equal to 0. Here your A is equal to 1, your B is negative 6, and your C is 9. So use the discriminant b squared minus 4ac and substitute the values into 8. You have b to be equal to, we are solving now. So we have b to be equal to negative 6 all squared minus 4, a is 1, and c is 9. A squared will give us 36 minus 4, 9 is also 36. The final answer is 0. So you realize that here b squared minus 4ac is equal to 0. And anytime b squared minus 4ac is equal to 0, it implies that the equation has equal square root, or sometimes just equal root. So that is the concept. Let's try some other examples. Find the value of k for which the quadratic equation kx squared plus 12x plus 9 equals to 0 has equal roots. Now, if we have this quadratic equation, which is kx squared plus 12x plus 9 equals to 0, if this has equal roots, here they have stated for you that it has equal roots. Because it has equal roots, you know that b squared minus 4ac must be equal to 0. That is the concept. What is your A in the question? Your A is equal to 2. Your B is equal to 12. And your C is equal to 9. Let's substitute these values into it. So we are going to have b squared, which is 12 squared, minus 4. A is what? 2. A is 2. Then C is 9 equal to 0. 12 squared will give us 134 minus 4 times 9 is 36. So 36 should be equal to 0. Then we can group like terms to get 36 should be equal to 144. Divide both sides by 36. Divide both sides by 36. 36, we cancel 36, so we have 2 to be equal to 144 divided by 36. And the answer is 4. So we have 2 to be 4. That is the answer. Our 2 here is 4. That's all. Let's move on to the next one. The root of the quadratic equation s squared minus 2. So let's write, we have s squared minus 2 into bracket 3q plus 1 x plus 7 into bracket 2k plus 3 is equal to 0. Now with this, we know that our a is the coefficient of s squared, so our a is 1. B is the coefficient of x. The coefficient of x is b, which is negative 2 into bracket 3k plus 1. Then our c is equal to the constant, which is 7 into bracket 2k plus 3. Now, here too, we said that we should find the value of k, where k is a constant. The root of the quadratic equation is this, where k is a constant, are equal. So here they are saying that the root of this quadratic equation is also equal. So once you see equal, what must come in mind is that the determinant b squared minus 4ac is equal to 0 because it is equal. Then you substitute the values into it. So substituting the values into it, b squared. So you are going to have negative 2 into bracket 3q plus 3 all squared. So all those values squared. Then minus 4 a. A is 1, so you can just write your own. Then c, and your c is also 7 multiplying 2c plus 3. Then all this, that is it. So b squared minus 4ac then should be equal to 0. So we can expand this. When we expand, the square will affect the negative. So negative 2 squared is 4, 32 squared. And it will multiply the bracket, which is 3q plus 3. This 3q plus 3, did I write it well? B is supposed to be 3q. It's supposed to be 3q plus 1. It's plus 1 here. Let me correct that one. We have 3q plus 1. 3q plus 1. So here we plus 1. That's the 3q plus 1. So we are going to get negative 2 squared, which is 4, into bracket 3q plus 1. The square will also affect it. So square here. Then minus. Here we need to expand. 4 times 7 will give us 28. So 28. Then into bracket 2q plus 3 to be equal to 0. Now let us continue. So here we are going to get 4. Then I'll expand the bracket. If I expand this bracket, I'll get 3 squared 9. So 9q squared. Then 2 times 3 is 6. So plus 8q. Then plus 1. So I have expanded the bracket. Then minus. I'm also expanding this one. Negative 28 times 2 give us negative 56. Negative 56 k. Then minus 20 times 3 is what? It's 84. So minus 84 to be equal to 0. So once you are done, you have to expand this bracket again. 4 times 9 is 36. So 36 k squared. Then plus 4 is 24 k. Then plus 4 minus 56 k minus 84 should be equal to 0. Then we group like terms. We have 36 k squared here. Then we have 24k minus 56k. 24 minus 56. 24 minus 56 will give us negative, this one is squared. So it will give us negative 32k. Then let's add a constant. 4 minus 84 will also give me negative 80 to be equal to 0. Now from here, let me see, I can divide both sides by 4. If I divide 36 by 4, I'll get 9. So when you get to this point, divide 2 by 4. Divide 2 by 4. You get 9. So 9k squared minus 32 divided by 4 is also 8. So 8k. Then minus 80 divided by 4 will also give you 20 to be equal to 0. Now when you get to this point, solve for q. Solve for q. You can use either the quadratic formula to solve for q, or you can use your calculator to solve for q. So by solving for q, I have k to be equal to 2 and negative 10 over 9. So that is the value of k. That is the value of k. So it means that if k is 2 or negative 10 over 9, the whole quadratic equation will have an equal root. Let's take another example. Find the value of k for which the equation 5k plus 1 s squared minus 8kx plus 3k equal to 0 has real root. Now take note that this time it is not equal, but it is real root. Now because it is real root, what do we have to do? You have to apply the discriminant b squared minus 4ac. This time it will not be equal to 0. Real root means it is either greater than or equal to 0. Take note of that. We explain that here. That whenever you have real root, it must be b squared minus 4ac greater than or equal to 0. So we have b squared minus 4ac greater than or equal to 0. Now with this, let's look at our a from the question. The coefficient of s squared is this. So that is a. The coefficient of s is this. This is b. The coefficient, that is a constant, is c. So you can see that our a is equal to 5k plus 1. our b is equal to negative 8q, and our c is equal to 3q. Substitute this into the discriminant. So we have negative 8q all squared, then minus 4a. A is 5q plus 1. Then the c is 3q. All should be greater than or equal to 0. Now let us simplify. Negative 8 squared is 64. So 64q squared. Then here, let me first expand. Negative 4 times 3. It gives me negative 12q. Then still multiplying 5q plus 1. I was multiplying those 4 by the 3q to get negative 12q. Then should be greater than or equal to 0. So we can go ahead and simplify 64 q squared. 12 times 5 equals 50. So we have negative 50q squared. Alright, so that is 50q squared, then plus 12q. 12q should be greater than or equal to 0. So once you have gotten here, we can simplify 64q squared minus 50q squared, which is us 4q squared, then plus 12q is greater than or equal to 0. When we get to this point, I can divide 2 by 4. If I divide 2 by 4, let me write it here. Divide 2 by 4. If I divide 2 by 4, I'll get q squared plus 3q. Then should be greater than or equal to 0. Now, this is a quadratic inequality. Q squared plus 3q greater than or equal to 0 is a quadratic inequality. To solve it, let's find the end point or the critical value. Find the critical value. So to solve for the root or find the root, find the root of this quadratic equation. So we assume that it is equation. So q squared plus 3q is equal to 0. So even though it is inequality, we will take it as equal to 0 and solve for q. So factorize q out, you will get q plus 3 equal to 0. Then we take each of them to 0. So q is equal to 0. And we also equate q plus 3 equal to 0. So here becomes q is equal to negative 3. Therefore, our values are, the roots are q is equal to 0 and q is equal to negative 3. But remember that we are not solving an equation, we are solving an inequality greater than or equal to. So remember that in the graph from here, you saw that if you have any quadratic equation where the a, let's look at the a, what is the value of the a in the quadratic equation? A is positive. We have the coefficient. In this question, the coefficient, look at a from here, q squared plus 3q. So if this should have been a quadratic equation, the coefficient of the q squared is 1, that is positive. and the coefficient of k is 3. So the k squared is positive. That is what I'm interested in. So because the coefficient of the s squared, in this case, we are using k as s. So because the coefficient of the squared, the 3a squared, is 1, which is positive, then we are going to apply this one. It means that the quadratic inequality will have where it is positive. So we are going to use the first one because a is positive and the inequality sign is also greater. So you realize that here we have the inequality sign to be greater, and we also have the coefficient of the s squared or the k squared to be positive. Therefore, the graph of this inequality is going to be, so because a squared, the coefficient is positive, is minimum. It's a minimum function. Then because it is greater than, we need to shield above the x-axis. We need to shield above the x-axis. Then these points are going to be the roots. So k is 0, then k is negative 3 must be on the left. So k should be negative 3, then k should be 0, like this. Always the smallest one will be on the left. Then what it means is that this portion becomes k is less than or equal to, because the reciprocal part k is less than or equal to negative 3 here. And here is going to be k is greater than or equal to 0. Therefore, k is such that k is less than or equal to negative 3, comma, use k. K is less than or equal to negative 3, k is greater than or equal to 0. So that is the solution set to the above question. So these are the values. It's a range of values. Now let's have the last one. Show that the roots of the equation k minus 2s squared minus 2 minus 3k x plus 2k equal to 0 are always real. Now to do this, to show that they are always real, what we can do is to determine the discriminant of this. Let's find the discriminant. So here we are saying that b squared minus 4ac, we are going to find this. Always real. Now for this quadratic equation to be always real, it means that we are going to prove that b squared minus 4ac is either greater than or equal to 0. So whenever we have b squared minus 4ac to be greater than or equal to 0, then we can conclude that it is always real. So let's start. Our b is the coefficient of s squared, which is k minus 2. Our b is the coefficient of x, which is negative into bracket 2 minus 3k. Then our c is the constant here, which is 2k. So let's substitute it inside. We are going to get b squared, which is negative into bracket 2 minus 3k, all squared. So b squared is this. Then minus 4, a is k minus 2, and c is 2k. So let us continue. Negative squared is still positive. Then we have 2 minus, the negative squared is positive. Then we get 2 minus 3k all squared. So we can expand this as 2 squared is 4. Then you will have 2 times 2 times 3. So 2 to 4 times 3 equals 12. So negative 12. Or better still, let me take them step by step so that we don't make mistakes. Let's first expand the bracket. When we expand the bracket, we have negative, so we are going to get negative 2 plus 3q. Then after that, we will square it like this. Then minus, I'm multiplying 4 by 2k, I'll get negative 8q. And it will also multiply 2 minus 2. So let us continue. Expand. Negative 2 squared is 42 4. Then minus 4 times 3 is negative 12. 2. Then plus 3 squared is 9. So 9 squared. Then here will be 8. Negative 8 squared. Negative is positive 15 k. Let us continue. So to continue, we have, let's work with the k squared first. 9k squared minus 8k squared will give us just k squared. That's for this part. Then with the k, we have 16k minus 12k. That will give us plus 4. Plus 4k. Then we also have plus 4 again. Plus 4 again. So now we have k squared. Now the k squared plus 4k plus 4, we can factorize it out. When we factorize out, we are going to get k squared. So let's factorize. So k squared plus, okay, k squared plus 2k plus 2k plus 4. Is that right? Then factorizing, k comes out, we have k plus 2. And when 2 comes out, plus 2 comes out, you still have k plus 2. Now, grouping like terms, you get k plus 2 multiplying k plus 2. And you know that k plus 2 multiplying k plus 2 will give us k plus 2 all squared. Now, because this is a perfect square, k plus 2 is a perfect square. Whenever you have a perfect square, it means that any value at all you substitute for k, you will get either 0 or you will get a number greater than 0. You can never get a negative. So we can say that k plus 2 all square cannot be negative. It cannot be negative because any value at all you substitute there, you will get either 0 or you will get a number greater than 0. So this implies that k plus 2 all squared is greater than or equal to 0. It can't be less than 0. Therefore, when the discriminant is great, therefore, e squared minus 4ac is giving us greater than or equal to 0. And hence, always real. Always real. That is it. It is always real. Because if it is less than 0, then it is not a real root. That is complex. But once you have been able to prove that k plus 2 all squared is a perfect square, and therefore its value is always greater than or equal to 0, then based on the discriminant, we are saying that the root will always be real, whether it will be equal real root or distinct root. Now let's solve this question in the slide. Find the greatest value of t, for which s squared minus cx plus 3 greater than or equal to t is true. Now, this very question is not what we are doing today. Find the greatest value. Yes, and we are going back to the greatest value. That's the maximum and the minimum values. And we have to find the greatest value of t, for which s squared minus cx plus 3 is greater than or equal to t is true for every x value which belongs to real numbers. Then the final one is to deduce that 1, 0 is the maximum point of the function f of x is equal to this. Now, solution. Now, given this question, this is s squared minus cx plus 3 greater than or equal to t. The first thing we need to do is to group all to the left-hand side. So we are going to get s squared minus cx plus 3 minus t. That will be greater than or equal to 0. Now, from here, you realize that this is a quadratic inequality. Here, our e is 1. That's the coefficient of s squared. The coefficient of s is negative c, so b is equal to negative c. Then c, which is the constant, is 3 minus c. That is the first b. Now let us look at this very question. You realize that the coefficient of this very quadratic inequality is a positive number. Because a is positive, if I want to sketch this graph, the graph of this function is going to be something like this. It's a minimum function. So it's going to be something like this. That will be the function. That's the first concept. Take note of that. So this point, let's say this is your y-axis. Your y-axis, your x-axis. So this very point is going to be your maximum. Find the greatest value of t. Now, so you realize that the maximum value, which is y, this value, let's say the maximum value is this point. You can trace it to the y. So y will be here. The maximum value this curve can attain is going to be from positive infinity. Remember that it is going to be from this point up to this point. The maximum value is this. Are we okay? Let me explain this well. Let me use a diagram here to explain it clearly. You have your x and your y axis. X, y. Now you realize that this curve, because the coefficient of the s squared is a, the a implies that. Now let's look at the question once again. Let's look at it once again. Let's go to the very first slide, then I'll show you something. Now look at the curves, these very curves. You realize that in this given curve, these are all quadratic graphs. Whenever the curve intersects the x-axis, we know that we are going to get a real number here and a real number here, and that is the root of the quadratic equation. When it touches the x-axis, you know that there will be only one root which is equal. We still have a red root. But whenever we have a case like this, what it means is that there is no red root. Let's take note. Whenever the curve is above the x-axis, there is no red root. Therefore, b squared minus 4ac is less than 0. One other thing you have to take note is that anytime there is a red root, it means that some portion of the graph is above the x-axis and some portion is below the x-axis. Remember that below the x-axis, y is negative, and above the x-axis, y is positive. So the function sum is positive and sum is negative. Whenever the curve touches the x-axis, it means that here y is 0 and here y is positive. So it is either 0 or positive. But whenever the curve is above the x-axis, then the curve is always positive. Always positive. Let's take note of this. We need this understanding to solve that very question. So let's go back to our question. So find the greatest value of t for which s squared minus cx plus 3 is greater than or equal to t. So here what we are going to do is that we'll find s squared. Let's take all to the left hand side. We are going to get s squared minus cx plus 3. Then minus c should be greater than or equal to 0. Now the question is asking us to find the greatest value for which this quadratic function is greater than 0. Greater than 0 means the whole quadratic function is y. So y is greater than or equal to 0. What it means is that if you have your function where here is y and here is let's say x, greater than or equal to 0 means the curve can either be up, above, that is going to be up. That is going to be the constant. So this is going to be the point where the function can be either greater than or equal to 0. If the function is equal to 0, you have the function up to this point. When it is greater than 0, the curve will be up like this. So we are looking at above the x-axis where the curve is above the x-axis. Whenever the curve is above the x-axis, then you know that it will not intersect with the x-axis. And whenever the curve is not intersecting with the x-axis, what it means is that there is no root to that quadratic function. Therefore, all what the statement is saying is that whenever the function is greater than or equal to 0, then it means that the curve will have a complex root. It will have a complex root. So another way of just going straight forward to say that a function will have a complex root is to just put the expression in this form, stating that the quadratic function is greater than or equal to 0. It means that the function is above the x-axis. It does not intersect the x-axis. Therefore, there will be no root. So this implies that there is no real root. And if there is no real root, then it means that it implies that b squared minus 4ac is less than 0. B squared minus 4ac will be less than 0. But in this case, we will not use only less than 0. The reason why we are not using less than 0 is because if the curve is greater than or equal to 0, then it means that the curve can either touch or it can be above. So you add equal to 0 to it. B squared minus 4ac should be less than or equal to 0. Then we use this one to solve. So let us proceed. Let's proceed to solve. So we are going to get, where are you? Let's take our A. From the question, our A is equal to 1. Our B is equal to negative 2. And our C is equal to, after grouping items, our C is going to be 3 minus 2. 3 minus 2. So these are the values. Then you substitute it inside. So B squared is going to be negative 2 squared. Then minus 4A is 1. So I can skip it. Then C is 3 minus B is, this one is equal to be C. C is equal to 3 minus C. Then should be less than or equal to 0. So to solve this, we still get C squared, then minus 12, then plus 4C should be less than or equal to 0. This is the same as C squared plus 4C minus 12 less than or equal to 0. Now, to solve this one, you can find the root. What will be the root? The root, after solving it, you are going to get the root to be, let me use the calculator to solve this straightforward. Or let me check, it's going to be negative 3 and 4. So negative positive 6 minus 2. So we'll get negative 6 and positive 2. So we get the root to be negative 6 and positive 2. So from here, we can just go ahead and sketch the graph. So to sketch the graph, we are going to get the graph to be something like this. Remember that the curve here, B squared minus 4AC, B was a negative value. That's the coefficient of the S squared is negative because B was negative C squared. Negative C squared is still C squared. Is that right? So we still have C squared minus 12 plus 4C. So this one, C is 1. That is, it's a positive value. Because it is positive, it will have a minimum function. So you sketch your minimum function like this. Then your roots are positive 2. The positive will come, no, the smallest one will come first. So negative 6 and positive 2 will be here. Then look at the sign. The sign here is negative. It's less than. The sign here is less than. So because the sign is less than, it means that we have to shade below. We have to shade below. So we shade below like this. So shading below, it means that our answer is going to be negative 6 is less than or equal to 2, less than or equal to 2. By looking at these two values, which one is the greatest? The question is going to find the greatest value. The greatest is for 2, C is equal to 2. And that becomes the solution. That is the greatest value is C is equal to 2. That is from negative 6 to 2, the greatest among them is 2. That is the solution. That is the solution of the A. Now the B is saying that we should deduce that 1, 0 is the maximum point. That one, we should be able to do it. Deduce that 1, 0 is the maximum point. We should deduce that 1, 0 is a maximum point. It's a maximum point. If 1, 0 is a maximum point, just forget about the 1, 0 and focus on the question itself. So now we have gotten our key to be 2. Since we have gotten our t to be 2, we are going to substitute it into the original question. Oh no, okay, this one is straightforward. Deduce that 1, 0 is the maximum point of f of x is equal to s squared. So let's write it. Deduce that it is the maximum point of f of x is equal to s squared minus 2x plus 1. So here they've given you the function straightforward. So because they've given you the function straightforward, you can just go ahead and solve it. For the sake of what you can use the completing of squares to solve it. Let me use the completing of squares for you. So using the completing of squares, I'll start by writing this one as s squared minus 2x. Then I will maintain s squared minus 2x. Then I will maintain the third one. So my third term is going to be the coefficient of x is negative 2 divided by 2 and square. When you divide by 2 and square, you get negative 1 squared. So here becomes plus negative 1 squared. Then you add and you subtract. So negative 1 squared again. Negative 1 squared. Then after that, you add your 1 to it plus 1 to it. That is going to be the first two. So once you are done with this, remember that always the first three terms can be written as x minus 1. Then you square all together. Then you are left with this part, which is negative into bracket. Negative 1 squared will be positive 1. Then plus 1. Negative 1 plus 1 will also be 0. So we have x minus 1 all squared plus 0. Now remember that we are going to compare it to the standard form. The standard form is giving us the standard form of the quadratic equation is giving us a into bracket x minus 1 x minus b or x plus b all squared then plus c, where this c is the maximum or minimum point. Then it occurs at s is equal to negative b. So in this case, the question is asking us to deduce the maximum point. So the maximum point is going to be equal to 0. And by the question, let me check it well. Deduce that 1, 0 is the maximum point of the function. This very question, it was supposed to be minimum, because the quadratic function has a minimum point, not a maximum point. Let's correct that. It was supposed to be a minimum point. Remember that the curve is going this way, so the minimum point will always be down. It will not be a maximum point. Let's take note of that. It's going to be the minimum point. Let me put it that way. It will not be maximum. The minimum point. The minimum point is 0, and it's okay at x is equal to positive 1. That is x minus 1 is equal to 0. Then you get x is equal to positive 1. That's the answer. So please go through this video and let's meet tomorrow at dawn for polynomial functions. Good morning to everyone.